Okay, and so for the first class today, for the first 2 hours, before we start the lecture, I will explain to you a little bit of introduction about this subject. Okay, so this is called. Not sure if you can see it. I hope that you can see. I think you can see it. But if you can't, you tell me. I can enlarge the screen. Okay, so this subject is also a subject in university. Subject is also known as course. Okay, course is the different name for subject. So this subject name or course name is strength of material. Okay, strength of material. In some institution in the world, for example, in the United States of America, this subject is known as mechanics of material. So strength of material, mechanics of materials are the same thing. It's just the difference in terms of name. So that is why if you are looking for a references book, some book, the title of the book is mechanics of material. Okay, because the author probably come from there. Okay, and in some other institution of the world, this subject is also known as solid mechanics. So solid mechanics of material, mechanics of material are the same thing. Okay, so what you are going to study in this subject, okay, so as the name implies, strength of material or mechanics of material is the study of the strength of a structure. Okay, you are going to study about the strength. You are study about the strength lah. Strength is stress. Stress and strength is the same thing lah. Stress is pressure. Okay. So it is equal to the load over area. Stress is equal to a stress over area, P over A. Stress is equal to P over A. So pressure over area. So that is what we are going to study in this subject as in general. So, but of course, in order to find stress, you have to find the value of forces, the value of this, the value of that, something like that. So in order to get the whole thing, you have to get this one first, something like that. You know what I mean? I think you know what I mean. Okay, so similarly, like if you are studying physics, in order to do physics, you have to have the knowledge in mathematics. So similar to this. So in order to get the strength of the value of the strength, you must have the value of forces first. You must have the value of this thing first. So before you can jump into conclusion. Okay, and so that is the name of the subject and what in general what you are going to study here. Okay, the course code or the subject code is BMM 1233. I am not sure. Okay, this code is for student from mechanical engineering program. Whether you are automotive or mechanical engineering pure, this is the code. If you are from other program, I do not know if any students that are enrolling for my class also come from other program, maybe chemical engineering, civil engineering, I don't know. Is there any? Okay, everyone is quiet. Probably.
I think no, sir.
Okay, so probably all are coming from the mechanical engineering field. Okay, so the BMM, Bachelor of Mechanical Engineering lah, and then 1, 2, 3. So one typically represent for first year student. Typically, this subject to be taken by the first year student. Because it is a core subject. Core subject means subject that everyone has to take. For mechanical engineering, for example, maybe for mechanical engineering, chemical engineering, civil engineering, everyone has to take the subject in the world. So if you are engineering student, typically this subject is compulsory. There is no excuse. So everyone has to take it. So that is the meaning of core subject. So that's why it is offered in the first year. When you are enrolling, then you take the subject. But in UNP, it is now implemented the open registration method, in which that you can take any subject at any semester. However, you have to be careful and smart enough to arrange and organize subject taken, so that in order to be graduated on time, you have already taken certain subject before you can take another subject. For example, if you want to take this subject, strength of material, you must first take subject static, because subject static is the prerequisite subject for this subject. It is because this subject, in order to study this subject, you must have the knowledge in static first. So that is why. You have to take a static subject first. Okay, and then 3 at the end of the code typically represent the credit hours to be carried for the weight of the loading for the subject. Okay, so if you are scoring good grade for the subject, it will be advantage because the credit hours is 3. So that means a higher weightage for you to make your CGPA stronger. Okay, and then this is the synopsis of the subject. You can read yourself lah. So we study about stress, strain, axis loading, torsion, bending, and
Sir.
yeah.
You present a slide, sir?
Huh?
Right now, are you present a slide?
No, the Excel.
Oh, because the slide is nothing show in slide. Sorry. The screen nothing show.
Everyone has the same experience, the same thing. Because I asked you whether you can see my screen or not. You say you can see my screen.
Yeah. But the screen not presenting a slide. Yeah. Just
Really?
presenting a Microsoft Team members. Yeah.
I see. Peliknya. Your entire screen. Okay, I share again. If it is not working, you tell me.
Okay, sir.
So, okay, can you see now the Excel?
No, sir.
No. Okay. Okay, you see now?
No.
Oh wait. No, cannot. Still cannot.
Yeah, still can't, sir.
Yes, sir. What do you mean? Yes.
No. Nothing show.
Saya ni nampak ni.
Awak nampak Excel awak? Awak nampak Excel saja?
Nampak.
Saya nampak juga.
Nampak sir.
Awak sorot je.
Nampak sir.
Awak sorot je tak nampak. Siapa tadi?
Oh, saya keluar luar.
Okey. Yang tadi tu sebelum dia cakap tadi tu nampak tak?
Nampak.
Oh, nampak juga?
Nampak.
Okey, so dia je tak nampak. Okey, sekejap saya stop balik Saya share balik. Lain kali janganlah diam je, cakap lah. Kalau nampak. Okey, yang ni sekarang nampak tak? Excel ni.
Nampak saya.
Okay, nampak. Okay, so I continue. Okay, so typically this subject is offered a student to take this subject in semester 2 when you are in the first year. But because it is open registration, you can take at any time you want. Okay, but typically student take this subject at semester 2 and take static in semester 1. Okay. And this is the course learning outcome ataupun subject outcome. So this tells you by the end of the semester, once you have finished studying this subject, what things or what knowledge that you should have, that you should already obtain. Okay, when you so that is the meaning of course outcome or subject outcome. So it has 4 course outcome. You can read yourself lah. Okay, this wrong what we call typing error, should be analyzed. Okay, you can read yourself. Okay, so that is the subject outcome. So it has 4 course outcome for the subject. Okay, and then this is called as the map of the CO to program outcome. So for your bachelor's degree, for example, you are enrolling for program of Bachelor of Mechanical Engineering. So in order to be a mechanical engineer and to be awarded the mechanical engineering bachelor's degree, you must fulfill all these 12 program outcome. Okay, so throughout 4 years you are in UNP, you have to fulfill all these 12 program outcome, PO. So in order to fulfill all these 12 program outcome, you have to take a sufficient amount of subjects, and each subject has its own course outcome, and each course outcome is linked to the attribute program outcome. Okay, it has its own it is connected to its own program outcome. So if you are not sure what is your program outcome, you can just Google program outcome UNP. You can go like anywhere. It's the same. Mechanical engineering or chemical engineering is the same. So it has 12. So PO1, what is PO1? What is PO2? So by the end of your 4 years in UNP, you must have an ability to apply knowledge of mathematics, natural science, engineering fundamentals, okay, and so on lah. So you already collected all these things in UNP, so that will prepare you to be a mechanical engineer. And then you read yourself lah, what is let's say PO12, an ability to recognize and the need for pressure ability to engage independence, something like that. Okay, clear?
Clear.
Okay sir.
Okay. Dah boleh tengok dah yang tu?
Oh dah.
Okay. And then in this subject, okay, there are three domain. There are three domain targeted for you. There are three domain. The way that the knowledge to be given to you. Okay, the way the knowledge to be given to you can be assessed through three domains. First domain is cognitive. Second domain is affective, and third domain is psychomotor. Okay, can you see my Google?
Yes, sir. Yes, sir.
Okay, so this is what I told you. There are three. There are three domain. There are three ways. There are three ways or three method how you can be evaluated. Okay, I give you the lecture. I give you the knowledge. I give you the information about the subject, and then you sit for the exam. So how or what is the method that I can evaluate you? How can I evaluate you? So there are three methods. First, cognitive, and then psychomotor and affective. Okay. So what is cognitive? Cognitive is to test your understanding or comprehension about the subject. So it tests your brain. Your brain, whether you understand or you comprehend with the thing that has been taught to you. That is cognitive. So it tests your brain lah. Your brain, your understanding. Okay, and then psychomotor. Psychomotor is the test whether you are good enough in handling something. If you are good enough handling tools, for example, you are handling machine, whether you are okay or not, whether you can use you what we are testing you whether you can use that tools or not, or machine or equipment. That is psychomotor. And then third is affective. Affective means we are testing your inner self, your inner beauty, your inner behavior, about your love, how love you are to the nature. For example, affective mean affectionate. Affectionate in Malay we can say it as a kasih sayang or sayang menyayang, something like that. So we are testing whether you are having the 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 what you call the awareness to take care of our nature. For example, how love you are to our environment. So that is an example lah. Okay, faham tak? However, okay, however, for this subject, we do not have the psychomotor and affective domain. We only have the cognitive domain because all DCO all will test your fundamental, your physics, your mathematics, yes, all these things, your science, because this subject only tests your science background, your mathematics background, your physics background. So we only have cognitive domain to test you here for this subject. So that is why this is C. C means cognitive. Okay? So in other subject, you may find that some program and course outcome map to effective and also psychomotor. So if it is psychomotor, it will be written as P something, P5 or P whatever lah. So this number C4, C6 represent the difficulty of that particular topic and question to be asked in the exam. So if you look here, So if you look here, this is 1, 2, 3, 4, 5, 6. Okay. So the higher the number, the more difficult it will be. Okay. For example, if let's say here, this one is C1, for example. If the CO1 will ask about C1, that means we only test you about remembering. For example, what is the meaning of for example, the question in the final exam could be what is the meaning of um, force, for example. Okay, so that is types of questions for cognitive one, C1, because it will ask you only about remembering things. Okay, however, this subject, we do not have that kind of thing. The only thing that we have is calculation and understanding. So when we give you the question, you need to analyze the problem and solve the problem. Okay, so therefore, for CO1 and PO1, you will be tested at this level, cognitive level 4, which is analyzing. Okay, analyzing. So similarly, the same thing also apply for another CO. So like CO2 in this chapter about a torsion, a circular, you will be tested in a level 6, for example. Okay. Any question?
No,
No, sir.
no, sir.
Because you are already in the second semester, I assume that someone else, other lecturer probably has explained to you all this thing before, but I am not sure. So I'll explain again so that you will have deeper understanding when you are explained, when you have been explained multiple times. Okay, I expected that, but I am not sure. Okay, for the assessment, this is the assessment method. We have quizzes, we have one test, and we have final examination. Okay, so for the quizzes, you will have 4 quizzes. You will have 4 quizzes, and each quiz will carry 5 times 4. Will carry 5%. Quiz 1, quiz 2, quiz 3, quiz 4. So you must do all the quiz in order to save you to pass the subject and in order for you to achieve a higher grade. Quiz will help to um, to boost your marks. Okay, to boost your marks to achieve a higher grade. Quiz will help a lot. Okay, and then you have test 1, in which that it will cover CO1 and CO2, and it will carry 20%. So this is the marks that it will carry. And then we have final examination, and it will carry 60%. Okay. This is the detail of the chapter. This is the detail of the topic lah. So chapter 1, chapter 2, chapter 3, and chapter 4. Okay. Supposed to be. Okay, I give you 5 slides. I give you 5 slides. On the 5 chapter. 5 chapter actually our syllabus starts from chapter 2, from slide chapter 2. Chapter 1 is just the introduction, it's just the refreshment, it's just the refreshing about what you have learned in the past, about your knowledge. So that is chapter 1. Okay, so chapter 1 actually does not include in the exam or test or whatsoever. So it's just a refreshing. And then chapter 2, chapter 3, chapter 4. So you see yourself lah. You see yourself later. I don't want to read this one by one. Okay. I think that's all for the introduction of the class. That is it. Okay, my name is Dr. Ramli, Dr. Ramli. So when you go to Kalam, you find my section. Okay, you find my section. Don't go to other people's section. And quiz will be given through Kalam as well. And that's all. If you have any question, you can ask now. If no question, you can ask now if you have question. But if you don't have question, I like to take probably 13 minutes, 13 minutes break because I have spoken for quite a long session and I am feeling tired. So we start the lecture at 1 o'clock, okay?
Okay, sir.
Okay, maybe we can start. Okay, this is the introduction. So the concept of stress. The main objective of the study of the mechanics of materials, or mechanics of material, or also known as strength of material, as I said to you, is to provide the future engineer with the means of analyzing and designing various machines and load-bearing structure. Okay, so design, analyzing stress, something like that, and design in mechanics of material, in or strength of material, is design means it's not like a fashion design. It's not like making a new clothes, something like that. But this design means you have to calculate and determine the size of, for example, uh, a shaft, the diameter of shaft, the diameter, the size of the beam. So that is the meaning of design in this subject. Okay, you have to do calculation and find the size of this thing. And then the second is both the analysis and design of a given structure involve the determination of stress and deformation. So there is a stress and the deformation involved. So deformation is the opposite. Deformation is the changes of the structure. That is the meaning of deformation. Let's say you have a beam. This is a beam. This is beam. So when you give load to this beam, so this beam could be bent. Okay, bend. So probably it will bend like this. So this bending is known as a deformation. Okay. So the review of static. So look at this example. We have a structure like this. This is wall, and this is wall. This is beam. You know what is beam? Beam or boom lah. In here it is. It says it is boom. So beam, boom or beam lah. So beam is the square shape. Square shape, and it is long like this. This is beam. So this one is this one, and this one is rod. Okay, rod. Rod has the shape of circle. So this is rod. Okay. So this structure, rod and beam, is designed to support a 30 kilonewton load. This is 30 kilonewton load. Here. For wall here, rod, beam, and we have 30 kilonewton load. So the perform a static analysis to determine the internal force in each structural member. So what is the internal force? What is F internal force mean what is this is B, A, C. So what is FAB and what is FBC? Internal force. What is force AB and force BC? So you draw the free body diagram. You draw the free body diagram. And you can see that this is the 30 kilonewton load going downward. This is at point A. At point A, you have force AX, and this is force AY. Similarly, at point C lah. So you to find what is FAB and what is FBC, you perform equilibrium moment and also equilibrium summation of all forces in X and Y direction. Okay, so moment at point C is equal to AX times 0, or AX times 0.6 from here to here, the distance, because moment is equal to force times distance. So moment at point C equal to 0, summation of moment at point C equal to 0, so is equal to 0 is equal to AX times 0.6 distance, that is the distance, plus, so if you consider this as a positive, so this one is going this way, so this means AX is positive, but this 30 kilonewton going this way, so that means it is negative, so plus negative 30 kilonewton times 0.8. So you get AX equal to 40.
Okay.
Yes, so you get this one. Okay, so when you get this one, and then you solve the summation of all forces in X direction equal to 0. So that means X direction is AX only to AX and CX. So AX plus CX equal to, and you know that this AX is equal to 40. So this one is 40 lah. So 0 equal to AX plus CX. So CX equal to minus AX. So CX equal to minus 40. Because you put this in here. Okay, similarly in Y direction, you have CY, AY, and 30 kilonewton. So going up, you consider as positive, and then you will get AY plus CY minus 30 kilonewton. This one. So AY and CY is positive is because it's going upward, and this 30 kilonewton is negative is because it going downward. So you got AY plus CY equal to 30 kilonewton. Sekejap eh. Okay. So you try to solve the free body diagram for the beam. So moment at point B. So you get all the summation of all moment at point B is equal to 0 when it is equilibrium. So if you consider this as positive and this one is going in opposite direction, you will get negative. Is times by 0.8, and then you will get AY equal to 0. And then you put in the previous equation, this one AY equal to 0, you put in here. This one AY equal to 0, and then you will get CY equal to 30 kN.
Saya nak tanya. Untuk yang previous equation tu, AY plus CY equal to 30 kN, kilonewton. Dia memang tak boleh divide by 2 je.
Divide by 2?
Maksudnya sebab maksudnya macam AY dengan CY tu lah sama kan. Tak boleh assume macam tu kan.
AY dengan CY ni sama. Value dia.
Maksudnya kalau bagi 2 dia akan dapat AY 15, CY pun 15 juga. Tak boleh kan?
Tak boleh. Okay. Tak boleh sebab dekat sini ada distance tau. Kat sini ada angle dan kat sini ada distance. So tak boleh lah. Tak boleh tak sama.
Okay.
So you get lah AC dengan CY so semua tu. Okay, in order to find what is FBC and what is FAB, so you use this what do you call this? Triangle je.
Pythagoras theorem.
Macam tu lah. Triangle theorem ni. So this one is FBC. Because this one is what do you call it? Hypotenuse. This one is 90 degree. So the opposite line, the opposite side is 5, and then you have this one is long. FAB is equal to 4, and this one is 3. And you know this is 30 kilonewton. This is 3, 4, and 5. So FBC divided by 5 is equal to 30 kilonewton divided by 3. Or equal to FAB divided by 4. And then if you solve this problem, for example this one, okay, so you cancel this one and you time this one with 5. So you will get the value of FBC. So FBC equal to 30 over 3 times 5. Faham tak? So you will get 50 kilonewton. Similarly, if you take only this one and this one, we got FAB over 4 equal to 30 over 3. So FAB equal to 30 over 3 times 4. You will get 40.
So untuk cari dia punya force tu sir, kita guna ratio kan? Untuk cari force tu, kita kena guna ratio. Betul? Macam tu.
Yeah.
Apa dia?
You have to use all kinds of things that has been that you have studied in the past. So this is something benda ni macam rule.
Rule, okay.
Rule tu. Rule benda tu saya tak ingat nama dia.
Saya pun tak ingat.
But it has this. It's like macam ni kan. This is A, this is B, this is C. So what is C? Something like that. It's like A square plus B square equal to C square, something like that. So in order to find C, you can find using this rule. So similar to this lah.
Oh, okay.
Okay. So you already got that FAB equal to 40 and FBC equal to 50. Okay, so the question asks you for the question. The question asks you, can the structure safely support the 30 kilonewton load? Okay. Given the dimension of the rod is 20 and the beam thickness is 50. So can the structure support 30 kilonewton?
Yes.
Yeah, from this answer, yes lah. But you have to prove using calculation. You cannot just say yes without proving the facts. You have to give the evidence. Okay, you have to give the evidence. So if you calculate for FBC here, for the stress in BC, so stress, you know that stress is equal to P over A. So tak? P over A. So you know P is how much? What is P?
30
P over A or F over A lah. Same thing lah. P or F is the same thing. So what is the P?
Is that 30?
No, this is 50 lah. So 50 over area. So what is the area? Because this is rod, what is the area? Area equal to?
Pi r square.
Yeah, pi r square. So you calculate the area, r equal to?
Centimeter. Apa tu? Centimeter.
Centimeter. So r equal to? R equal to 10. 10 milli is 10 to the power of minus 3. So 10 times 10 to the power of minus 3 square. Okay, so you calculate pi 10 times 10 to the power of minus 3 square. This is A. So when you calculate, you use the calculator, you will get this as the area, this one. And then if you divide 50 by this value, you will get this value. Okay. And then when you check in the table, the allowable stress for the steel, if this rod is made from steel, the steel has the allowable stress equal to 165. This one only will give you 159 MPa. So it does not exceed the allowable stress. So that means this structure is safe to support 30 kilonewton.
Sir. Nak tanya kenapa kita tak buat untuk member AB?
Kejap Kita akan buat juga untuk AB. Kita akan buat juga untuk AB. So awak kira lah sendiri nanti. So stress AB sama dengan F over A ataupun P over A. So F dia ialah 40. 40. A dia ialah area sama dengan, kira lah 50 ni kali dengan berapa. Kalau dia bagilah, dia bagi
50 dah 50 je.
Kalau dah 50. Kalau dia punya struktur ni lah. Maksudnya ni, B ni. Okay, ni 50. Ni pun 50. Okay, Dik. Faham tak? Ini 50 ni, 50 mm. Bukan 50 kilonewton ni. Bukan ini. Dimension. I'm talking about the dimension. Okay?
Okay, Doktor.
Design of new structure requires selection of appropriate material and component dimension to meet performance requirement. For reason based on cost, weight, availability, the choice is made to construct the rod from aluminium. Okay, so previously for this structure, you decide to use steel. In which that the allowable stress is 165 MPa for steel. Okay, for steel. And then you calculate, and then you decide that you calculate from the calculation, the stress is okay. This is safe. However, the company that you are working with are losing lots of money because of the COVID, and they wanted you to replace this steel with aluminium. The reason is aluminium is much cheaper than steel. Steel is more expensive. So they ask you to change this structure. Instead of using steel, they say use aluminium. Okay. So now, what is the allowable stress for aluminium? Okay, you decide whether this structure still safe. So if you use aluminium, you have to find in the table or in the theory what is the allowable stress for aluminium. But the allowable stress for aluminium from your research equal to 100 MPa only. Okay, and then, so when you change the material to aluminium, the properties will be different lah. So the question asks you, what is the required diameter? Because this aluminium is stronger than steel. Steel is very much stronger than aluminium. So when it is less stronger, when it is weaker, it will need a higher, a bigger diameter or a lower diameter, or smaller diameter.
Lower.
When it is weaker, the aluminium is weaker than steel. That means the aluminium will require bigger diameter. Faham tak?
Bigger diameter saya.
Bigger lah sebab dia lemah. Jadi dia perlukan struktur ni lagi besar untuk dia tampung berat tu.
Sekejap.
Contohnya macam lidi. Lidi, kata awak ada lidi. Ni lidi. Ni kayu balak. Ni kayu balak. Kayu balak ni sebab dia strong. So awak perlukan satu je untuk awak jadikan dia jambatan untuk menyeberang satu parit. Tapi lidi ni awak perlukan banyak. Beribu-ribu lidi. Untuk awak jadikan dia sebagai jambatan untuk menyeberang satu parit. Jadi perlukan banyaklah ni. Sama juga ni perlukan besar. Yang ni perlukan kecil. Faham tak?
Okay, saya dah nampak. Thank you.
Okay, so you calculate. What is the required diameter. So you know that FBC is equal to 50 kan?
Yeah, 50.
So from the calculation, stress is equal to F over A. And this stress is equal to 100, allowable stress is equal to 100. 100 MPa equal to F 50 kilonewton divided by area. Area is pi r square. Pi r square or pi d square over 4. So area is equal to pi r square or pi d square over 4. So you can put here area is equal to pi d square over 4. So what you want to find is the value of diameter. So if you solve this problem, you will get D is equal to 4 times if you solve this problem, you get this one. Malas saya nak tunjuk. Nak saya tunjuk kat tu. So this is your 100. This is your stress equal to F over A. So stress is 100 MPa and F is equal to 50 kilonewton over pi d square over 4. So you change this 100 MPa is times 10 to the power of 6 and 50 is times 10 to the power of 3. And then pi d square over 4. So you bring to here. So pi d square over 4 equal to 50 times the power of 3 divided by 100. Okay, and then d square equal to 50 times 10 to the power of 3 divided by 100 times 10 to the power of 6 times 4 over 5. Okay, and d you calculate times 4 over 5, and then you set all of them. So you will get the value of d. You just use calculator and you will get the value of d. So from the calculator, you get this value. So the new diameter would be 26 lah, 26 mm. you round to bigger lah, because if you just use 25, it is still not enough to support 30 kilonewton load. If you use 26, it will be enough.
So sir, untuk calculation, kita tak ambil titik puluhan ya?
Calculation yang mana yang tak ambil titik bulan? Yang ni ke?
Contoh macam calculation kan, so terus ambil 26 kan. Kalau ikutkan calculation ni dapat 25.23 something point belakang dia. So kita akan ambil nombor bulat.
Okey, sepatutnya boleh je kalau nak ambil nombor ni tepat-tepat ni.
Alright, okay.
Tapi kalau ambil tepat-tepat ni, maksudnya cukup-cukup je, faham tak?
Faham?
Cukup je. 30 km. Kalau awak letak load tu 30.05, benda ni terus patah.
Oh.
Faham tak?
Okay,
Biasanya kita akan lebihkan sikit. Contoh macam lift. Awak naik lift. Lift tu kata boleh naik 10 orang sahaja maksimum.
Okay.
Tapi sebenarnya tolerance dia mungkin sebenarnya 20 orang. Teori dia, tapi nak selamat dia cakap macam tu 10 orang je. Sebab kalau ada manusia tak ikut arahan, tiba-tiba dia masuk 15 orang dalam lift tu. So selamatlah. Sebenarnya tolerance tu tinggi lagi. So awak tak boleh letak cukup je.
Okay.
Faham tak? Kamu juga macam ni. Kalau dah cukup je, tak lebih sikit. Dia pun nak. Kau bundarkan.
Okay.
Dia minimum lah. Dia minimum. Macam itu. And then axial loading. Nombor kedua kita settle kelas. Axial loading. So axial loading adalah loading. Axial loading is the normal loading lah. Normal loading or normal stress. So in which that the normal stress occur when the force is perpendicular to the area. So let's say this is the force, or the force is in this direction, and this is the area. Okay, if you look in 3D, so this is the area. So in which that the area is, this is the force, the area is perpendicular to the force. This is force, this is area. So the area is perpendicular to the force. This is known as normal stress. Okay. If the force, this is area. If the force is parallel, to the area, this is known as
shear stress.
Yes, this is known as shear stress. Shear stress. So this one perpendicular, force and area is perpendicular. This one, force and area is parallel. So stress has two. Has two. One is normal stress, and one is shear. So normal stress is typically written as this symbol. Okay, this symbol, normal. Shear stress typically written as this symbol, tau. But the equation is still the same. F over A. Only the direction of the F and A, either perpendicular or parallel. This is a centric and eccentric loading. So for centric loading, the load is straight to the center. The axis of the load is passing through the center. Okay. This is centric. For the eccentric is the load exists just not passing through the central, the central of the body because of the structure of the body lah. So when you give load like this, because of the structure is like this, because the structure is not strict like the central loading, so it will produce a moment. So when you press here, this will give a moment to this direction. So this structure try to bend itself. So that is why you have a moment here. This is shear. This is shear loading. This is shear stress, sorry. So shear is something that you actually try to, maybe I can say you try to cut at the body. This is your body. You give force here and you give force here. So you try to cut. So the area is here. So if you look in 3D form, this is the structure. So you this is the area. And you give force here, and you give force here. So you actually try to cut the structure in here. So the value of the shear stress can be calculated using the same equation, in which that this is called as tau. Shear stress is known as is pronounced as tau. Tau equal to F over A or P over A lah. This is single shear. You pull this to this direction, and then you pull to this direction. So you actually try to cut in here. Okay, this is single shear. But in this case, okay, so in this case you will get like this lah. But in this case, you try to cut in here and in here. So this is double, 1 and 2. Double. So it become like this lah. Faham tak? So the calculation is still the same. Tau
Boleh.
equal to F over A. And this one, tau equal to P or equal to F over 2 area. Because it has 2 area. So that's why 2A. This is bearing stress. So the bearing stress is still the same. It calculated using stress equal to F over A. So in which that A is equal to this one. This is the diameter. This is the length. So actually you will see this as this is the area lah. So this is T. And this is A. This is D. So A is equal to T times D. So that's why we got T times D. Faham tak? Okay lah, so I think we already finished until this slide. We continue tomorrow, right? Tomorrow, I think, our class.
Yes.
Yes, sir. Tomorrow morning. At
Tomorrow morning,
9.
9 o'clock. Okay,
Yeah.
so I'll see you at 9 o'clock tomorrow. class dismissed, and I will share you the link for this recorded lecture. Once the recording lecture is ready is ready lah, is finished loading. Okay, so have a good day. See you tomorrow.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you.